This technical short video is brought to you by Dave Kameen, VP of Marketing for JPS Interoperability Solutions.
Let's talk about the RSP-Z2 interoperability basic configurations. Now we're going to talk about the second major capability of the Z2. That's the cross-connected with backhaul mode. We're going to look at that, and we're going to look at the setting choices. So you can see in the slide that we're looking at now, Channel 1 local and Channel 2 local look just like the other settings. And so with cross-connected with backhaul, the choices for either side, Channel 1 or Channel 2, are RoIP, RTP, radio, SIP, or USB headset. So that's the same for Channel 1 and Channel 2. And this is a little different now. Before we had two parallel independent paths. We now have a repeater type mode at the top with Channel 1 and Channel 2. If Channel 2 receives a radio signal, then Channel 1 is going to transmit it out that radio, and vice versa. If Channel 1 receives a signal, it's going to go out Channel 2 as transmit audio. And so we've got a repeater type mode, and then we have the capability of either one of those being backhauled through the typical backhaul settings as we've seen before. At the bottom here we have bridge, RoIP, RTP, SIP, and JPS via. And so repeater mode, and then that can be backhauled to anywhere with the bridging channels to many other Z2s or Z1s, to JPS RoIP, to any of our products, to RTP, many other vendor products, Cisco Call Manager, Cisco recorders and other companies' recorders. Through SIP can go to many of the JPS products as well, and also to a SIP PBX or a SIP client on a computer, for example, or even just a SIP phone. And JPS via, using JPS RoIP to go to the via server, which then would be available as audio either way to any of the users on the JPS via server. Here we see a block diagram of the same thing. On the left, either channel, we have radios or consoles or telephones. That would be PSTN. And so they can go back and forth between each other as a repeater, and then all of the audio goes out the backhaul side, and it can be going through SIP, RTP, or JPS RoIP, and it'll be a single patched audio stream. Both receivers and both transmitters on the radios, all that audio will be sent via the stream, and it could be sent to a web browser, a JPS gateway, another RSP-Z2, it could be a SIP phone or a SIP PBX, it could be Cisco Call Manager, or it could be JPS via smartphones, or it could be a recorder. So many opportunities there to interconnect to other devices through those protocols. And in the standalone mode, the Z2 can create a local patch between its two analog interfaces, radio to radio or radio to PSTN. It's a dynamic patching capability controlled, and it's audio monitored via the unit encrypted web-based graphical user interface. This joint audio can travel via IP in a single stream using the desired transport protocol. So here we see a simpler diagram, and we see the same thing as before. We just removed the Z2 to make it more evident that both those radios, or both the console and the radio, or any devices we have out there on the right, can be connected together, and then also that audio can be supported by SIP, RTP, or JPS RoIP in a single patched audio stream, going out to web browsers, JPS gateways, other Z2s, a SIP phone or a SIP PBX, Cisco Call Manager, JPS via smartphones, recorders, or any other devices by OEMs that can support SIP, RTP, or JPS RoIP. Now we see that we have two radios on the right, or we have a radio on the right, dispatch consoles, and we see we're going to different products with protocols, a Z2 with RoIP, SIP, or RTP, SIP PBX with SIP, Cisco Call Manager using RTP, JPS via using JPS RoIP,